7.3, trig identities. When we are working with trig identities, we need to remember that it's not just the certain ones that we have seen so far. There is going to be an accumulation of identities that we will be working with. But today, our main focus for this first video is going to be the identities that we did discover in chapter 6. So, hold on, I hit that button to scroll it all the way down. Okay, so in chapter 6, we went over the quotient identities, which is for tangent and cotangent, that they can be written with sine and cosine as fractions. We went over the reciprocal identities, and there are actually 6 reciprocal identities. These can be rewritten as sine equals 1 over cosecant, and so on. If you are looking at your trig identity sheet, and if you don't have that out while you are watching this video, you need to pause this and you need to get out your identity sheet. So if you look at the reciprocal identities, there are actually 6 of them, and there are 6 of them, 1 for each of the trig functions. So we have a lot to choose from there. We have the Pythagorean identities, but remember, you can manipulate these. Meaning you can move things around. If I want this first one to equal sine, I would subtract cosine squared, and then I would square root. Here it's already secant squared, maybe I just need a square root. So you can manipulate them, and again, if you're looking at your trig identity sheet, you see some of those manipulations already, where this one, where they're all the way they are, but this first one is set so it's equal to sine. Then it's set so it's equal to just cosine. And then the second 2 are switched around, so you have secant by itself and tangent by itself. And this third one where cosecant is by itself and then cotangent is by itself. So you do have things that we need to keep remembering that we have learned. Then we also have the even and odd identities, where this is going to help us with maybe what do I do with a negative? I have a negative angle for my cosine, but theirs doesn't. We need to remember that cosine is even, same with secant, and your negatives go away, but with tangent and sine, your negative actually moves to the front. So things that we do need to remember from chapter 6. So now we're going to take these identities and we are going to first, in just example 1, this video is only going to be example 1, where you're being told, hey, try this. You can establish this identity by using this first, or things that we need to recognize that we can do to make our life easier. So when we get into example 2 and you're actually establishing an identity where you're proving the left side equals the right side, you will have a pathway to follow. Oh, I'm adding, I need to do this. Or, oh, I'm dividing, I need to do this. Please take very good notes here. It might be worth it to watch this a couple of times. You're going to get out of it what you put into it. If you're not willing to put the time and the effort into this, then no, you're not going to get this stuff, and you will struggle through every single section that we have left in chapter 7. We need to be able to prove identities. We need to be able to prove an equation. We need to be able to recognize what can I do to help me with that proof, to help me establish the identity. So these first 4, very, very important. And these first 4 go with day 1 for 7.3. For 7.3, day 1. You need to do those practice problems, please. So then you are set up for day 2. So in this first one, it says simplify cotangent theta over cosecant theta. So I'm going to start by rewriting that. Cotangent theta over cosecant theta. I want to rewrite by using sine and cosine. So it says in terms of sine and cosine. So I need to think of ways of how I can rewrite cotangent and cosecant. So I'm going to look at my identities. Now look at your quotient identities. You have a quotient identity that uses cosine over sine. So cotangent is cosine of theta over sine of theta. Now we need to rewrite cosecant. Look at your reciprocal identities. Cosecant is 1 over sine. So this is a quotient identity, and this one I'm going to use a reciprocal. Cosecant, look at it. Cosecant is 1 over sine. So now I have a fraction divided by a fraction. When I am dividing fractions, I'm actually going to multiply by the reciprocal. So I'm going to multiply this sucker up here. So this is sine of theta over 1. So now I have, I'm not going to do any cancellation yet. I'm going to actually show you the multiplication. Cosine theta times sine of theta. So that's the numerator times the numerator. And denominator, so sine times 1 is sine. Well, now I can actually cancel out my sines. I can cancel. This is the same as x times y over y. Y's cancel. You're left with x. So here I am left with cosine. So that one wasn't so bad. I used two very simple identities, quotient and reciprocal, and then I used my arithmetic skills. I know how to divide fractions, and I know how to multiply fractions. So that made this a lot easier for me. So I am finished. What's nice with the establishing the identities is you actually know when to stop. Where here we're just going to keep going and going and going until we can't anymore. The establishing, we know when to finish. All right, in B, I need to sneeze. Okay, excuse me. I need to show that the left side equals the right side by multiplying the numerator and the denominator by 1 minus sine of theta. So I'm going to rewrite the left side. Cosine of theta over 1 plus sine of theta. Now it says I need to multiply by 1 minus sine of theta to the numerator and the denominator. So let me show that first. So here's multiplying to the numerator, and here's multiplying to the denominator. My reason for this, first, my indicator is if you look at the right side back here, your numerator of what we're looking for is a 1 minus sign. So somehow I do need to get a 1 minus sign in the numerator. And it just so happens that by multiplying the denominator, which is 1 plus sign, times 1 minus sign, I am multiplying by the conjugate. And the conjugate is the exact same thing as the denominator, but with a different sign in the middle. This automatically gives me a difference of squares. So my multiplication is going to be a lot easier. So remember, you're multiplying. So it might be easier if you see these in parentheses. You're multiplying the original fraction by 1 minus sign. I am going to leave the denominator. I'm not going to distribute. You might be thinking, hey, I can distribute this. That's not what I'm going to do. My reason for not wanting to do that, if I distribute, don't write this, but if I distribute, I would get cosine of theta minus cosine of theta times sine of theta. Well, now I don't see my 1 minus sine theta that I want. I want 1 minus sine theta. So I'm actually going to leave it as cosine theta times 1 minus sine of theta. However, on the denominator, I don't have a 1 plus or minus sine of theta. I have cosine. So somehow I need to rewrite this. Because this is a difference of squares, I just need to multiply 1 times 1, which is 1, and sine times negative sine. So think of this as 1 plus x times 1 minus x. So 1 times 1, x times x. X times x is x squared. So sine times sine is negative sine squared. So this is actually almost done. I have a 1 minus sine squared. Look at your Pythagorean identities. We need to recognize when you see a 1 with a sine squared or a cosine squared, we need to be thinking Pythagorean identity. Even if you see a cosine squared by itself, or a sine squared, or a tangent squared, or cotangent squared, secant squared, cosecant squared, you need to be thinking, hey, maybe I can use a Pythagorean identity because it's squared. So a couple things you do need to look at. So if I use the Pythagorean identity, oh my gosh, I cannot spell. So if I look at a Pythagorean identity, I have one that says cosine squared of theta equals 1 minus sine squared theta. Oh my gosh, look. 1 minus sine squared theta, 1 minus sine squared theta. And what does that equal? Cosine squared theta. So that's what I'm going to put in its place. So I'm going to use substitution. So cosine of theta times 1 minus sine of theta all over cosine squared theta. Now some of you will see what we can do next. Some of you might not see what we can do next. So I'm going to rewrite the top again. I know I'm showing every step, you guys, and I know this is a lot of writing. It is what it is. You guys can skimp on the work and you might miss something. This is going to take a lot of room, but you got paper. If you make a mistake, don't even bother erasing. Just start over. It's not a big deal, you guys. Don't get frustrated. Cosine squared. How do I get a cosine squared? Well, if I look back here, I got a sine squared because I did sine times sine. So cosine squared is because it's cosine times cosine. Now you might see that, oh, wait a second, we can cancel a pair of cosines because I've now written as multiplication, which gives me 1 minus sine of theta over cosine of theta. And that's what I was looking for. So you guys actually did and established the identity right now. We had a left side equals a right side, and we worked to get the left side to equal the right side. It is a long process, I understand that, but you are going to have to put the effort in. All right, 2 more. C. Simplify by rewriting over a common denominator. Why would we have to rewrite using a common denominator? Well, I'm adding 2 fractions. You cannot add fractions unless you have a common denominator. So I'm not going to rewrite this. I'm going to cheat a little bit. My common denominator is going to be sine times cosine, putting the 2 denominators together. So I'm going to multiply this side by cosine, this fraction by sine. U is the same as theta. Please do not be confused with that. On your identity sheet, you see x and y. That's in place of theta. In your book, you're also going to see alpha and beta being used as angle measures. So don't get confused when you guys are seeing different variables being put in place of theta. So let's see, I multiply the top. I'm not going to distribute yet. I don't want to distribute yet because what if I don't need to? then I just did work I didn't have to. So I'm just going to rewrite this first. Cosine times 1 plus sine. Then it's plus, now I'm multiplying sine times cotangent minus cosine. And then our denominator is sine times cosine. So I rewrote it over a common denominator. Now I need to simplify. So I don't see anything that I can do right now, so I am going to distribute. So I distribute cosine, I distribute sine. So now cosine times 1 is cosine. Cosine times sine is cosine times sine. Plus sine times cotangent minus sine times cosine. All over sine cosine. Okay, that definitely does not look simpler, but now I can use this to actually start to simplify some things. Cosine times sine is the same as sine times cosine. Those are the same thing. So when I'm looking here, I have a positive sine cosine and a negative sine cosine. Those cancel. So now I am down to cosine of u plus sine u times, I forgot the u, sine of u times cotangent of u all over sine u times cosine u. Okay, let's see. What can we do now? Because I need to try. I need to see if I can take this further. So look at your identities. See if there's something there that we can rewrite. What I hope that you see is that cotangent can be rewritten as cosine over sine. And then if I bring this sine back up here, it's times sine. You could write that over 1. Your sines cancel. So it just becomes cosine. So now I have cosine of u plus cosine of u. Isn't that weird that sine times cotangent is just cosine? You are making it simpler. But if you don't recognize when you can use identity and quotient and Pythagorean identities, you are very much going to struggle with this. Over sine cosine. Even now I'm not done. I have two cosines, a cosine plus a cosine. X plus x is 2x. So guess what cosine plus cosine is? 2 cosine over sine cosine. Cosines cancel. 2 over sine of u. Now I think in your notes that's where I finished, but I can actually rewrite this as an even more simple or simpler, however you say it. I can make this look nicer. 1 over sine. Sine's in the denominator. So let's just pretend this said 1 over sine. Well, that's a reciprocal. 1 over sine is cosecant. So guess what 2 over sine is? 2 cosecant. Here I didn't know when I needed to stop. With the establishing the identities tomorrow, you will know when to stop. But here I just kept going until it was very simple and there was nothing else I could do. So here I am finished. Back here I could have been finished like in your notes. I stopped your notes here because it was written with sine. But I could take away the fraction and rewrite it with cosecant. Again, if you guys need to be watching these questions over again, pause it, watch it over again. Be ready to ask me questions in class. We will have a homework day coming up. But we do need to be making an effort. All right, last one for this video. Simplify by factoring. Factoring is something that we do tend to struggle with, and that is frustrating that we are still struggling with it, but it is what it is. When we're trying to factor this, factoring, we need to remember, is breaking things down into multiples. I want to write this times this. It might be easier if you guys use variables here. So I'm going to take sine squared of u minus 1. And then I have tangent of u, sine of u minus tangent of u. I'm going to write these with variables, and I'm going to work with just the top first. I'm not going to work with top and bottom at the same time. So I'm going to use x. So I'm going to say, okay, sine is going to equal x. So this would be x squared minus 1. I really hope we remember how to factor an x squared minus 1. This is a difference of squares. So this is x plus 1, x minus 1. Now in place of x, I am going to put back sine. So this is going to be sine of u plus 1 and sine of u minus 1. So I have now factored the numerator. Now I need to work on factoring the denominator. Now if you are really good at this, you understood that, you might actually be able to factor from here. Sine squared, sine times sine. 1 times 1. And then plus or minus, because this is a difference of squares. Now I'm going to work with the denominator, and I'll use a different color so you guys can see the separation. Here I'm going to say tangent is going to be y, and I'm going to say sine. I'm going to keep sine as x. So this is going to become, so tangent was y, so y times x minus tangent was y, so y. Now for factoring, you need to recognize that both of these terms, you have two terms. You have a yx and you have a y. Both of those terms share a y, which means you can factor out a y. If I take a y out, I'm left with x minus 1. Are we okay with that? I hope. You're dividing by y, essentially. And if you're not sure, you can distribute back and make sure you get y times x minus y. And I do. So now I'm going to put my trig functions back. Y was tangent. So I'm looking back here. Y was tangent. So this is going to be tangent times x was sine. So sine of u, and then it was minus 1. Okay, that actually helped me out a lot because now I can cancel a sine u minus 1, which I wasn't going to see unless I factored. So I am now left with sine of u plus 1 over tangent of u. That one's pretty much done. You might have to take this one further in the next example. So just kind of think, how could we rewrite tangent just as a bonus? Tangent becomes sine over cosine. And then because I'm dividing by a fraction, I would need to flip and multiply. So something to think about, that if you get stuck sometimes, we need to continue. There might be other things we can do. Here, I'm okay with you guys stopping there because it didn't tell us where to stop. It just said factor, simplify by factoring. So we factored by changing to variables, so it was something we knew. Then we put our trig functions back, and then we canceled. And this is what we were left with. If you got to watch it again, you guys. You're going to see more of these in the next two videos for 7.3. Questions, please come ready with them tomorrow. See you then.